Assalamu alaikum and hello everyone. My name is Yousuf and I am back with another exciting video. I welcome you to my YouTube channel Yousuf Solves. I am here to solve some key questions of financial management courses. These questions generally form part of post-graduation or master's degree program. If you are new to my channel, please do check my previous videos. Please like, subscribe and share it with your fellow students who are taking relevant courses for financial management. Also, if you have any question or query which you want me to solve or make video for, please drop me a comment below so that I can try to support you. You can also send me queries to my email address which is given in the description. Without any further delay, let's jump directly to the question and its solution. Today we are looking at another question of financial management whereby we'll be calculating periodic receipts in future value in both ordinary annuity and annuity due. So the questions we have that you can see in the screen, I will just quickly read it. You need to have $50,000 at the end of 10 years. To accumulate this sum, you have decided to save a certain amount at the end of each of the next 10 years and deposit it in the bank. The bank pays 8% interest compounded annually for the long-term deposits. How much will you have to save each year to nearest dollar? So, question number 4. Let's just jot down the data we have. Fair value we want is $50,000. I is 8%. N is 10 years. Timing is at the end, which means ordinary annuity. We need to find R. So we will use the formula for ordinary annuity, which is F equals to R 1 plus I power n minus 1 upon I. Let's put values in the formula. Fair value is 50,000. R we don't know. 1 plus I is 8%. Power 10 minus 1 upon 8%. So if we solve this equation, this will come out to be 14.486. So in other words, my R would be 50,000 divided by 14.486. So R is dollar nearest to $3,451. So this was the question for ordinary annuity. Now, if you read question number 5, it says same as question problem 4 above, except that you deposit a certain amount at the beginning of each of the next 10 years. Now, how much will you have to save each year to the nearest dollar? So now all things remains the same. Except timing is beginning of the year, which means annuity due. So the formula for annuity due is fair value equals to R 1 plus I minus N, not minus, sorry. 1 plus I N minus 1 upon I multiply by 1 plus I. So please note here that the formula for ordinary annuity and annuity due is the same. The only difference is this factor, 1 plus I factor. So if it's an ordinary annuity, you will not use this. If it's an annuity due, you will use this formula. this formula means that you will add 1 plus I additional at the end of your formula. So let's add the value here now. 50,000 equals to R 1 plus 8%, N is 10 divided minus 1 divided by 8%, 1 plus 8%. So if we solve this formula, this equation, this would become approximately like this: 50,000 divided by R into, or in the brackets, 15.645. In other words, R would be $50,000 divided by 15.645, which would become approximately R $3,196 approximately. So why, if let's just quickly do a comparison of ordinary annuity and annuity due. My fair value is same, 50k. Here is also 50k dollars. My I is 8%. Here is my also 8%. My N is 10 years. Here is my N is also 10 years. But my R here is coming as 3451, and here my R is coming as 3195. So why is this difference in both of the values, both dollars? The difference is because of this, the formula. If I just jot down the formula here also, here the formula is FV equal to R 1 plus I and minus 1 upon I. Here the formula is F equals to R 1 plus I and minus 1 upon I into a factor of 1 plus I. Just because of this 1 plus I, you are getting the amount of the periodic payment low as compared to here.